Alright, so logarithms and exponentials are inverses. What does the word inverse mean? Because now someone says it's like the inverse of something else. At the opposite, yeah. So therefore they are opposites in everything. That's important. Circle that, underline it, highlight it. Know that they are opposite. So because we're talking about opposites, up in the top corner, I want you guys to write this down. So what's the opposite of domain? Range. What's the opposite of x? Y. Alright, so now you can understand the opposite of exponential graphs will be logs. Everything that we kind of just flip-flop. Alright, let's look at this first graph. Would this be an exponential? Would this be a log? There's an x and the exponent. So this would be exponential. Did you guys see anything after my exponent? We can basically just put plus 0. We know that my asymptote for exponential graph is the very back. So my asymptote, you can already write in, is going to be y equals 0. Go ahead, let's go ahead and draw in our asymptote. Because we already know that my asymptote was 0. Y equals 0. Alright, I want to get some points so I can draw it. So let's go to Desmos. Alright, so my equation is y equals 10 to the power of x, right? That's what my graph looks like. Did you guys use Desmos on your quiz or your TI? Okay. So you guys see my asymptote's at 0, right? It looks like it gets really close to 0, but it's never touching. So let's get some points. I'm going to go to my table. All right, so let's get some good points. Clearly, I can't graph 2 and 100, right? So I'm going to write down, and once again, like we don't have to have perfect points. That's okay. I don't expect you guys to all have perfect. So -2 and then 0.01. That's really close. -1 and 0.1 and 0 and 1. Let's type in -4. Let's see what that gives us. Oh, no, that's not good. We want -3. Let's go +4. 5. All right. This should be enough points. I'm trying to see if there's another really easy one to plot. So I'm going to plot -2, 1, 0, 1, -1, 0.1, and 0, 1. So if I were to graph this, I know that it is just going, that's my graph sketched. Alright, so what's my domain here? What's my domain? How far left and right do I go? Negative infinity to positive infinity. Alright, what about my range?
1,
Huh?
1, 3, 0.
We start from the bottom, right?
Mm-hmm.
Okay, think about it like this, guys. Your asymptote is either a floor or it's a ceiling. Okay, meaning if it's a ceiling, that means that it's the top of like your graph It's the top of your X. If it's the floor, it's the bottom. Will this be a floor or ceiling? Floor. So let's start here. So my range is from 0, and I'm going up to where? Infinity. Let's leave our parentheses. All right, your increasing interval. First of all, am I increasing or decreasing? I'm increasing. Do we all agree that we're increasing? Okay, this is kind of iffy on our quiz. We always go left to right, and you ask yourself, from left to right, am I going up or am I going down? We're going up, so we're increasing the entire time. I am not decreasing. And don't just leave that blank. Either put like no or cross it out or something so I know that you didn't just skip it. All right, my y-intercept was 0, 1. Or you could write y equals 1. You can't just write 1. Ooh, zeros. Am I touching the x-axis at all? No, because that's my asymptote. So I don't have any zeros. And then my end behaviors. Going towards negative infinity, that's my left. Going towards positive infinity is my right. My left end behavior is getting closer and closer to the asymptote, which is what? Huh? What's that line called? The asymptote, which is what? 0. All right, my right end behavior is going all the way up towards positive infinity. All right, so that was basically a review. You know how to do that. Huh? Now it's time for the logs. So, if I... Am I going crazy? Okay, let's see. No, okay. So, is this a log equation or exponential?
Log.
Log, because it literally says log. Alright, this is what's new. Okay? For your log, let's go to Desmos. I haven't done a log graph in Desmos yet, so let's all do it together. So, I have y equals. Alright, your log is probably going to be in a function. Don't just type in the word log. I don't know if that works or not. Okay, so if you go to the miscellaneous tab, functions, and then misc, and then hit, I think it'll be this log. You would hit log, and then automatically a parentheses will pop up. You hit x, because that's basically what it is, log of x. So we've been doing exponentials and we had a horizontal asymptote. Now we're doing logs, we're going to have a vertical asymptote. Okay? So let's go ahead and let's write some points down. A lot of these are undefined. Let's see what comes up if I type in some higher numbers. Alright, so let's just, we don't need that many. So let's write down 1, 0. What's the easy one to plot? We can do 3. 3 was 0.47, which is close to like 0.5. And then 5 is 0.69. Alright. So, once again, I'm just sketching it. This was basically in parentheses. I have 1, 0, 3.47, 5.69. I'm going to make my axis a little darker so I can never see it. You guys can go ahead and, it looks like, well, you guys haven't really learned that yet, but give me a second. Alright, so 1, 0 is there. Alright, So I'm basically getting really close. That's what my graph looks like. So we can tell from this that my vertical asymptote was 0. So draw your dotted line vertically. We now have a vertical asymptote because we are doing logs. Nope. And I'll show you a hint to remember it. It's kind of a cheesy hint, but it's a new mind device that I just remembered. All right, so my domain from left to right, actually, all right, so my domain is going to be from my asymptote on. Okay, so let's start at my asymptote. Where does my graph start? At 0. And we're going until positive infinity. Which is kind of the opposite of what we did with our range. With an exponential graph, my domain was always all real numbers. So guess what my range is going to be? How far up and down am I going? Into negative infinity to positive infinity. So those two kind of flip-flop. We used to look at my range, go from down to up, but now my range is always going to be all real numbers for logs. Alright, my asymptote, if it is vertical, would that be x, would that be y? For vertical, x will equal 0. Okay, when we had exponentials, that was a horizontal, that's why it was y equals. But now, my asymptote's going straight up and down, so that is vertical. Alright, from left to right, am I increasing or decreasing?
It's increasing.
I'm increasing. So I am increasing
0.
from 0
Infinity.
to infinity. Am I decreasing at all? No. So basically, when you're looking at your increasing and decreasing, it's going to be starting from wherever your asymptote is. My y-intercept, I don't have one. I'm not even crossing the y-axis. That's where my asymptote is. So we don't have one. But we do have a 0. I'm crossing the x-axis at 1, 0. Look at your table and see where y is 0. Or you can write x equals 1. You only have one indicator here. It's going towards the right, your right arm. I'm going up towards infinity. So here's your little hint. I don't know if you have room to write it somewhere on your paper. Forgot what writes this first. Oh, think about this. What does that remind you guys of? All you fashionistas? Louis Vuitton, alright? So, Louis Vuitton reminds me that the L is log, and the V is a vertical asymptote. Once again, I know it's cheesy, but what you guys trying to figure out is the exponential horizontal or vertical. Think about LV. L means log, log means vertical. Does that make sense? LV, log, vertical. That's what you have to think about.
But won't it just say log every time? Will it not say log every time?
It will say log, but then it's just going to say asymptote. See how it says asymptote? I don't want you guys to put y equals there. So if you think about LV, then you'll know that it has to be x because V is vertical, and then you can draw it. Alright, we've seen this. The same concepts are applying. That A can tell me three things. What can it tell me to do? What if it was a negative A? It will tell me to reflect. What if it was smaller than 1? What did you say? Compress.
Compress.
If it's smaller than 1, we're going to compress. What if your A is larger than 1? You will stretch. Alright, your H can tell me two directions. If it is a negative, it is going to tell me to go right. If it is a positive, it is going to tell me to go left. Your K also tells me two directions. What are they? Right, if it is negative, we're going to go down. If it is positive, we're going to go up. All right, your vertical asymptote is going to be x equals h. That means it is going to be the opposite of whatever's inside there. So if you had like x minus 5 there, your asymptote would be x equals positive 5. So you have to be very careful because what we did with our exponential graphs was to look at the last number. Our k told us what our asymptote is. For log, whatever's inside the parentheses will tell you. Or you can look in your graph it and see where it gets really close to but doesn't.
So it would be positive H.
So your domain for logs are going to be h to infinity or negative infinity to h, meaning your asymptote. And your range is going to be all real numbers. Those two things just flip. Alright, move on. Alright, translations. B, you should know this by now. Look, Curtis, my first one, A. I have two transformations. What do those two things tell me to do? What's the negative tell me to do? To reflect. What's the positive 3 inside the parentheses, left or right? Left 3. Okay? Michelle, on letter B, you have two transformations here. That 1/3 tells me to do what?
The third one?
1/3.
Oh, to compress.
Compress. And what about the +1? Up one. Some of you guys get confused about that +1. If they don't have a parentheses here, that doesn't mean we're going left. That means that's basically our K. That's our last number. Josue, the third one is all yours. We have 3 transformations. What are we doing here? What's the 3 paths telling you to do? Okay, so normally a fraction tells us to compress, but remember it has to be bigger than 1. Is 3/2 bigger than 1? So we're going to stretch. Alright, what about that +2? Left or right? And then the -1 at the end? Down. All right, so You guys have 30 minutes to work on these 5 graphs. Practice 1, 2, 3, 4, and 5. Don't worry about the second page. There's 4 graphs there. We're not doing those. You can skip those. I want you guys to look at number 3 though before you start working on your own. On number 3, it says ln. That means natural log. Alright, so in Desmos, I'm pretty sure there's a spot for that. It just means it has a different base. Y equals negative. Okay, so right above the log. There's log there. ln, which is your natural log, is there. And then you can type in x plus 2 and then plus 3. You're able to see, looks like here my asymptote is at negative 2. It gets really close to that negative 2, but it doesn't. That's where you see it straighten up. And if you look at your graph, you know your asymptote is negative 2 because it is the opposite of what's inside the parentheses. So your vertical asymptote will be negative 2. Okay? So go ahead and spend about 20 minutes on this and I'll put the answers up.